Dear friends, Maths Aspirants is a collective of mathematics students, research scholars, and teachers across India, started in 2017 by myself. And we used to arrange online problem solving sessions and online test series to help the students who prepare for different national level competitive examinations. As a part of the online problem solving session series, today we have a session on selected problems from ordinary differential equations. And we have Ms. Unnati Shukla with us to handle the session. Ms. Unnati currently pursuing M.Tech in data analytics at IIT ISM Dhanbad. She qualified IIT JAM CSIR-NET with JRF and GATE examinations. And also she used to take classes for IIT JAM and NET aspirants since 2 years. And she is a very active participant of our math aspirants community and a great contributor in many of our programs. And as all of us know that the forthcoming examinations of IIT JAM and GATE are very near. GATE examination is going to happen on February 4th and IIT JAM is on February 11th. So I'm sure that today's session will be really helpful in your last round preparations. She will discuss previous year questions from the area of ordinary differential equations. I'm sure that will certainly help you to boost your performance in these coming examinations. So I welcome everyone to this program, and I would like to express my sincere gratitude to Unnati for being with Math Aspirants community, and hearty welcome, Unnati. Yes, thank you.
Thank you, sir. Thank you once again for me this wonderful opportunity of interacting with students and sharing some of what I know. So in today's session, we are going to talk about the previous year questions, and we are going to discuss the previous year questions of mainly IIT JAM exam, which will also be helpful in your GATE exam. So let's focus on the previous year question first of like 2023 questions. Then we'll move on to 2022 questions. And I observed one thing, that in 2022, the pattern of questions was a little difficult compared to 2023 and other years. So we'll also be discussing those difficult questions. So yeah, let's get started without any further delay. Okay, so let's begin with this first problem. We are going to discuss these 2023 problems in a row, then we'll move on to the 2022 paper. Okay, so these are some warm-up questions. Let's hop on to them. So the first question we see is a basic linear differentiation, right? And we have, this is an initial value problem, and there are some options given there. So the options talk about this alpha. So let us first solve for the solution of this equation. Plus alpha y is equals to 0. So how do we solve this equation? This is a linear differential equation. We can just separate the variables. We can solve it using linear differential equation. Here, if I take, using the formula for linear differential equation, if I take p is equals to alpha and q is equals to 0. So the integrating factor will be e raised to power integration of alpha with respect to x, right? So this is going to be e raised to power alpha x. This is my integrating factor. Now for the solution part, we can do y into integrating factor is equals to integration of q into integrating factor, which is 0 plus some constant. So your solution becomes y into e raised to power alpha x is equals to some constant. You could have also solved this by variable separable method. This is a very simple equation. So all the thing lies in the options. You have to judge the options correctly. Solving this question is very easy, as we can see. So y is equals to c times e raised to power minus alpha x is our final solution. But before going into the options, let us first try to apply the initial condition, which is y0 is equals to 1. So when x is 0, it gives us y is equals to 1. So let us put x equal to 0 and y is equals to 1. So what we get is c to be equal to 1. So the final solution is e raised to power minus alpha x times c, which is 1. Okay, this is our final solution. Now let us consider the options. So the first option says that there is an alpha such that y1 is equals to 0. I want you guys to solve this question. Keep solving these questions with me. I might be asking 1 or 2 questions in between. So keep solving these questions with me, okay? So there is an alpha such that y1 is equals to 0. Can any value of alpha make this y equal to 0? Because y is an exponential function and y can never be 0. So according to this, first option is not correct. Then it says that there is a unique alpha such that the limiting value of y at x approaching to infinity goes to 0. Yes, limiting value of exponential function can go to 0. But they're saying that there is a unique alpha. We'll have to be careful there. Okay, does there have to be a unique alpha? If I take alpha greater than 0 for any alpha, let me take just 2 different alphas. Let me take alpha is equals to 1 and alpha is equals to 2. In both of these cases, I can see that e raised to power minus x and y is equals to e raised to power minus 2x. Both of these cases, if I apply limit x approaching to infinity, what I'm going to get is 0. And similarly for this function, for this solution. So there does not lie, there is no unique alpha. There are actually infinitely many alphas. So B option is also incorrect because of this, word unique alpha. Otherwise, it would have been correct. There is no alpha such that y2 is equals to 1. Okay, there is no alpha, they are saying, such that y2 is equals to 1. Let's see if this is correct. So our solution was y is equals to e raised to power minus alpha x. They are saying that there is no alpha such that y2 is equals to 1. Let's see. If I put y is equals to 1 and x is equals to 2. So this is what I'm going to get, minus 2 alpha. So if I put alpha is equals to 0, can this be equal to 0? Obviously, e raised to power minus 2 into 0 will be equal to 1. So if for alpha is equals to 0, you can get y2 is equals to 1. They are saying that there is no alpha. So this is also incorrect. Now the remaining option will be correct only because this was a multiple choice question. So D is correct. But how D is correct? We can also analyze that. They are saying that there is a unique alpha such that y1 equal to 2. Okay, y1 is equals to 2. Let us put y equal to 1, y equal to 2 and x is equals to 1, e raised to power minus alpha into 1. So what we are going to get is e raised to power minus alpha equal to 2. So if you want to find such alpha exists or not, you can find that very easily. You can say that taking log both sides, minus alpha is equals to log 2, e base log. So alpha is equals to minus log e to the base 2. This is your unique alpha. So now this condition of uniqueness is correct. So D option is correct. This was a really easy question. You just needed to find the solution. As long as you see a differential equation which is easily solvable, you just solve it and check the options. That's the correct way. We'll also see questions where you do not need to solve the equation, differential equations, because it is not always possible to solve a differential equation and go with the options. Sometimes it uses calculus and some properties of calculus. So it is not always recommended to solve for the differential equation. But if the options, it will always be analyzed with the options whether you should solve the equation or not. So we'll be analyzing all those questions in today's session. I hope it is clear to everyone. If you have any doubt, you can post in the chat. We'll take those doubts by the end of this session. Okay, this next question is related to orthogonal trajectories. It says, consider the family of curves with a real parameter k greater than -5, then the orthogonal trajectory to this family of curves passing through 2, 3 also passes through this. Okay. So it is clear that we'll have to solve for the orthogonal trajectories for this question. And k is some, and k is greater than -5. It's given there. Okay. Let me first find the differential equation, and then I will solve for the orthogonal trajectory. So in this question, it is clear that there is no way but to find the orthogonal trajectory. So we'll be solving this question. Okay, we'll be completely solving this question. If I differentiate both sides with respect to x, what will happen? You can solve with me. 2y dy over dx is equals to 2 into 1 plus 4 dy over dx, and that's it, right? So let me just simplify this. If I take 2 common from both sides, I'm going to get x plus y dy over dx is equals to 1 plus 2 dy over dx. Okay, let me value of dy over dx, and then I'll change dy over dx to minus dx over dy to find the orthogonal trajectories. So this will be x minus 1 is equals to 2 minus y dy over dx. I took this here and I took this here, right? Now dy over dx comes out to be x minus 1 divided by 2 minus y, right? So how do we find the orthogonal trajectories for a differential equation? We know that orthogonal trajectories and our curves have perpendicular slopes. So the slope of orthogonal trajectory and the product of our curves is going to be -1. So the slope of the orthogonal trajectories are going to be minus dx over dy, and this stays the same. Now what we can do, we can see that we can apply, variable separable method. So let's do it. Dy divided by 2 minus y, and I'm integrating side by side. This will be equal to, this will be negative, dx over x minus 1. What I did was, I took x minus 1 here, and I took dy over here. So dx over x minus 1 is equals to dy over 2 minus y. I can write this as dx over x minus 1 is equals to dy over y minus 2. Can anybody find the solution and tell me what will be the orthogonal trajectory? Try to find the solution before me and tell me, okay? I'm solving. Is equals to log y minus 2 plus log c. Basically, this is going to be into c, by the property of log. So y minus 2 will be equal to x minus 1 over c. Am I audible to everyone? I need to confirm because... Can anybody tell me, am I audible?
Yes.
Okay. So try solving for this. What was the condition? At x equal to 2, y is equals to 3. So this is our point, 2, 3. So by putting this point, we are going to get 3 minus 2 is equals to 2 minus 1 divided by c, which is basically c to b equal to 1. So now, what our orthogonal trajectory becomes is y minus 2 is equals to x minus 1 over 1, which is this. I can also simplify it more. Y is equals to x minus 1 plus 2, which gives me x plus 1, right? So what do you think? Which option should be correct? Can anybody tell me? Y is equals to x plus 1. Another point that this curve will satisfy. They're asking us another point from these options that this curve will satisfy. Which one is it? I'm waiting for your answer. This curve satisfies which of these points from the option? Yes, anybody? Option A, yes, correct. Because in option A, we see that y is equals to x plus 1. X is 3 and y is 3 plus 1. So basically, we have this to be correct option and all other are clearly incorrect. This was a multiple choice question. The questions before 31 are multiple choice questions. These are mixed questions, 1 or 2 mark question, in which you have to just pick out one correct option and all other are incorrect. So if you are able to identify 3 incorrect options, very good. You can just take the 4th one, and you just need to identify just one correct option, right? Or if your strategy can be 2-way, identify 1 correct or 3 incorrect to save your time, right? Okay, so this was a question in which we identified the correct option. Okay, now let's come to question number 33. Now this is a question after the serial number 31. So this is a multiple select question. It was of 2 marks. So let's see how will we analyze this question. So they are saying that y is defined from root 2 over 3, root 2 by 3 to infinity to r. Okay. Can anybody tell me how will I solve for this differential equation? Do I actually need to solve it? The number 1 question. Do I actually need to solve it? Or will it be enough not solving? Just checking the options. What do you think? Should we solve it? Does it seem easy to solve? Solvable or not? Let me just write this. 2x minus y dy over dx. You can just unmute and tell me. Don't shy. Okay. I can also rewrite this as
exact differential equation.
Okay, someone is saying exact differential equation. So if the differential equation is exact, it is, I think, the easiest differential equation to solve in the world. So what we can do, let's solve for it, because we won't be able to identify the correct option without solving it. Because the option says that you put x equal to 3 in y, you put x equal to 2 in y, and you talk about y dash and all that. You'll have to solve for it, clearly. So let's do it. This is our m, this is our n, and we know how to solve for exact differential equations. Let's see if this is exact or not. So del m by del y will be equal to 2, partial derivative with respect to y, and with respect to x, we get 2 over. That's really nice. It's an exact differential equation. So we'll directly integrate. Just a second. We'll directly integrate, right? So it was 2x minus y dy, right? But for y, we can't directly integrate. We'll have to integrate in the y all those terms which are independent of x. So in order to integrate 2x minus y dy, we'll have to take out all those terms which are dependent on x. So 2x will be removed. Okay, so this becomes, let me write it, minus y dy plus, and we can integrate the x term as it is. I mean, m term as it is. This is m, this is n. So 2y minus x, you can directly integrate it with respect to x, is equals to some constant. You can solve before me. Minus y square by 2 plus y square minus x square by 2, something like that. Am I correct? No, it will be xy, okay, because we are integrating with respect to x. Okay, very nice. So this is equal to some constant. Now let's see if they have given some conditions. Yes, y1 is equals to 3. The given condition is that you put x equal to 1, and then you get y equal to 3. Let's do it. Minus 9 by 2 plus 1 into 3 and minus 1 by 2 is equals to constant. So this will be equal to 3 xy minus x.
I think 2xy.
It is 2xy.
Okay. That's fine. 2 3 is 6 minus 9 and 1 10 by 2 is equals to constant. So C is equals to 6 minus 5, which is 1. Okay, nice. So our final solution is y square by 2 plus 2xy minus x square by 2 is equal to 1. I can rewrite this as, if I want to, negative 4xy minus x square minus y square is equals to 2. I hope I'm correct. If I do any calculation mistake, you can always, tell me. Okay, now let's check the options. The number one option says if you put x equal to 3, you get y equal to 1. Let's see if this point satisfies or not. Let's try to substitute x equal to 3 in this and y equal to 1. X equal to 3, y equal to 1. So what I get is 4, 3, 1 minus 3 square minus 1 square is equals to 2. 12 minus 9 minus 1. Let's see if this is equal to 2 or not. 3 minus 1. This is equal to 2 actually. This is actually equal to 2. Yes. So this point is satisfying. So this is a correct option. Option A is correct. Well, if you try to substitute x equal to 3 in this equation and you find the value of y, you can also do that. You substitute only x equal to 3, then you get a quadratic in y. Then in that way, you can also get two values of y. One of them will be equal to this, y equal to 1. One of them will be y equal to 1. So you can also do that way, but this is an easier way to check. Second option says that if you put x equal to 2, you get y is equals to 4 plus square root of 10. Please check with me. Let's see. 4xy minus x square minus y square is equals to 2. So x is equals to 2. You get y is equals to 4 plus square root of 10. Let's check that again. 4 plus square root of 10, right? Okay. Now substitute. So 4 into 2 into 4 plus square root of 10 minus 2 square minus 4 plus root 10 squared. Let's see if this satisfies or not. This is 8. 8 times 4 is 32 plus 8 root 10 minus 4 minus 16 plus 10 plus 8 root 10. This is what we get now. So 8 root 10 and 8 root 10 will cancel each other because there is a minus sign. This will be 32 minus 4 will be 28 minus this will be 26. So this is equal to 2. This also satisfies because RHS was equal to 2. So this means that second option is also correct in the same way. Now let's talk about the third option. They are saying that y dash is bounded on this. Next option is saying y dash is bounded on 1 to infinity. Let's see. Okay. Let's talk about y dash. What is y dash? Y dash was given to us, right? So y dash was dy by dx was, I can write this as, I'll just write it here. It's easily. If I find dy by dx, that is y dash, from here what I will get is negative of 2y minus x divided by 2x minus y. I can rewrite this as x minus 2y over 2x minus y. So this derivative will not exist at 2x is equals to y. This is clear. Okay. So how do we solve for this? I mean, how do we check if y dash is bounded on this point or not? So we can put y is equals to 2x in our solution and check that. So let me just do it. Y is equals to 2x in our own solution. Our solution was 4xy minus x square minus y square is equals to 2. Y is equals to 2x was a point of problem. Here this y dash was not defined. So let's see. If I put y is equals to 2x, I'm going to get a quadratic in x and I'll get the value of x for which it will not be defined. Okay. But I want to get the value of y. Okay, let's do it. 4x into y, 2x minus x square minus 2x whole square is equal to 2. Okay, this will be 8x square minus x square minus 4x square is equal to 2. This will be 7 minus 4, 3x square is equals to 2. So x is equals to plus minus root 2 by 3 is a point where you will face the problem. Root 2 by 3. Yes. So our differentiation, our dy by dx was this. Dy by dx was x minus 2y, 2x minus y. So our function, our derivative is not defined at x is equals to plus minus 2 by 3. So that means at x equal to 2 by 3, it won't be defined. And if you find the limiting value around this point, it will be unbounded. You know, if you find limit x approaching to root 2 by 3, y of x, then this will be infinity, approaching to infinity or minus infinity. And thus y dash is, sorry, y dash x. This is dy by dx. So y dash will be unbounded around this point. And they are saying that it is bounded. Option C says that this is bounded. No, this is not bounded. So around, sorry, this is incorrect. So A and B are correct, but C is incorrect. Why is it incorrect? What we did was, we just find out the point of problem. When y is equals to 2x, there is a problem. So we substituted y is equals to 2x in our solution, and we got two values of x where we could face the problem. Right. So at x equal to plus minus 2 by 3, we might have the problem. So around this point, when you find the limiting value, it will be, the y dash will be unbounded. The limit will be infinity, because this will be like an asymptote for the solution. Y is x equal to 2 by 3 or x equal to minus 2 by 3. So there was the point of problem. So this was not bounded in this interval. Around this point, it won't be bounded. It is talking about the open interval. If it would have talked about the closed interval 2 by 3, this statement would have been wrong, because the function dy by dx will not have been defined, right? So option D says that this is bounded on 1 to infinity. Yes, it will be bounded from 1 to infinity. Why? Because we have seen that we can only face problem at x equal to root 2 by 3 or minus root 2 by 3. And around these points, when you find the limit at these points, at these 2 points, only then the limit will be unbounded.
Ma'am, you are muted.
Sorry, Unnati, please unmute.
How it happened? When did I got muted?
Okay, now it's
Okay.
okay.
If anybody has any doubt in the previous question, because I was also muted, you can ask. Then we'll move on to the last question of 2023. Then we'll see some exciting questions of 2022. This is like a warm-up session before 2022 questions. These questions are easy. Okay, we are good. So we got these options. This was an MSQ. We got A correct, B correct, and D correct. There is someone who is muting everyone in the call. That's why I'm getting muted, sir. I again got
Okay.
muted. There is
Okay,
some Began.
let us. So,
Okay,
dear
okay.
participants, please don't create any disturbance. Just attend the session, and
Okay.
I will look into that, Unnati.
Yes, sir, sure. Okay, let's move on to this question. This seems interesting. Until now, we have seen just first order differential equations. This is another question where we'll see something different. Y double dash minus 2y dash plus y.
Ma'am, your screen is not presenting.
My screen is not presenting. Okay. What's happening? Is it visible now?
Yes, ma'am.
Yes, tell me, how do we solve this kind of questions? This is a second order linear differential equation. How do we solve for it? And this is a non-homogeneous one. Let me write the conditions also. We have something called auxiliary equation and particular integral in case of non-homogeneous ones. So let me find the auxiliary equation. This is a very basic linear differential equation with constant coefficient. This is going to be very easy to solve. So how do we solve for it? D square minus 2D, this y double dash, sorry, this will be replaced, taking the place of t square. This will be acting as d. So taking this into consideration, auxiliary equation will be d square minus 2d plus 1 into y is equals to 0. We'll look at particular integral here, but before that, let me find this basic solution. This is basically d minus 1 whole square is equals to 0, right? So I get two values for d, and both of these two values are same. D is equals to 1 and d is equals to 1. Okay. So for these repeated values, what kind of solutions we see? Y is equals to C1 plus C2 into X, where C1 and C2 are arbitrary constants, e raised to power X, right? So this is our solution. But this solution is incomplete until we talk about the particular integral, because this was a non-homogeneous one. So what do we do in the particular integral thing? We have exponential function here, also very easy. We have this coefficient equal to 1, e raised to power 1 into x. So we'll substitute 1 here. But substituting 1 here, you know that this will be a case of failure. So what should we do now? To deal with this case of failure, what do? We just differentiate the denominator and we multiply by x. Okay, again, this will be a case of failure, right? So we'll again differentiate the denominator and we'll multiply it by 2. Right? This is how we do. So our complete solution becomes, let me just write it, C1 plus C2 times x into e raised to power x plus half x square e raised to power x. The condition was y0 is equals to 0, the first condition, right? So when you put x is equals to 0, this becomes 0, this becomes 0. So you are left with, this becomes 0. You are left with C1 is equals to 0. So let me just quickly erase this C1 because this will become 0. And this becomes our new solution. And y dash 0 is given to be, y dash 0 is minus half. So y dash here will be C2 x plus 1. It's very easy to find. I'm just writing this y dash. It was x squared plus x squared plus 2x, I guess. Yeah. Y dash 0 was minus 1 by 2. So y dash was minus 1 by 2 when x was equal to 0. So minus 1 by 2 is equals to C2 times x was 0. 0 plus 1 e raised to power 0 plus half x is 0. So this becomes 0 e raised to power 0. So C2 into 1 is equals to negative half. So C2 becomes negative 1 by 2. Now taking all of this into consideration, I'm going to get y is equals to 1 by 2 x e raised to power x plus half x square e raised to power x. I hope this is our solution and this is correct. Okay. Is equals to negative half. Now they are asking at y is equals to 1, what's the value of this function? Oh my god, that's so easy. Who doesn't know this? This will be same, minus 1 by 2, 1 into e raised to power 1 plus 1 by 2, 1 square into e raised to power 1, and this comes out to be 0, and 0 is your answer. 0 is the most favorite guess. If you're not able to solve for any question, my favorite guess in numerical answer types is just 0, because you find at least 1 or 2 questions in any exam with the answer 0. So whenever I'm not able to solve any numerical answer type question, because there is no negative marking in that, I just pick 0. Okay, I'll be just sharing this sheet after this session. So I hope we are clear with the 2023 questions. If you have any doubt, you can just clear your doubts here. Then we'll move on to some difficult questions of 2022. These were just warm-up questions. Okay. We are good to go, I guess. If you're facing any network issue, you can just immediately tell me, because I wouldn't get to know. Sorry. Okay, let's move on to this. Now, how do we solve for this? This is a 2022 question number 21. This is a differential equation, and what they are asking is, they have given this equation, they have given a condition y0 equal to 0. This is not a linear differential equation, first of all. This is not a, this is not a second order differential equation. This is a nonlinear differential equation. And it seems very difficult to solve. You can't separate the variables. So what do we do? And option says it has a local minima maxima. Yx is strictly increasing, decreasing. So option is not asking, first of all, options are not asking for the solution. So this gives us a hint that we don't need to find the solution. Are you getting my point? In this case, the options are the hint that you don't need to find the solution, because you haven't studied any method to solve for this differential equation. Even if you have, options tell you that you don't always need to solve the differential equation just because there is a differential equation. Well, actually, this is not a question of differential equation, but some students might be stuck in the exam and think that this is a differential equations question and I'm going to solve it. It will waste your time. This is actually a question of calculus, but we have taken this question here just to make it clear to you. Okay, let's solve for it. So with all what we have been given to us, y0 equal to 0, and let me write dy by dx as y dash of x is equals to y square minus 1 plus cos of x. Okay, what do we do now? For some function to have a local minima or maxima, we need to consider y double dash's sign. It should be greater than 0 for all x belongs to. But they're talking about, let's see, in option C, they're talking about some open interval minus delta to delta. Okay, let's see how will we solve it. If you're getting some ideas, you can also share. You will have to go to double derivative. Let's go. But let's try to substitute 0 in this. Can we get something? Y dash 0 is equals to y0 squared minus 1 plus cos 0, right? But y0 is 0 and it's given. So 0 squared minus 1 plus 1. So this is equal to 0. So ultimately y dash 0 is 0. Y0 is also 0. Now let me move on to y double dash. Let's see what we can do from there. Now y double dash x will be equal to 2y into y dash minus 0 plus minus sin x. Is my pace okay to you? Am I going too fast or too slow? Can anybody tell me, is it okay, or should I just, change my speed? I'm trying to make it clear to everyone. So, what we can do now? Let me just write it as y double dash x is equal to 2y dash minus sin x. Cool. So y double dash 0 is equal to 2y0 into y dash 0 minus sin 0. Okay, nice. We know that y0 is 0, y dash 0 is 0. So this becomes 0 minus sin 0 is 0. So again, y double dash 0 becomes 0. And we are not able to get somewhere. because y double dash 0 became 0. Okay. So in case where our second derivative test fails, what do? We move on to the third derivative test. So let's try to find the third derivative and see if it's possible to do so. I'm gonna differentiate this one. 2y and y dash will be differentiated using the product rule. 2y dash, and this will be as it is, so it will be y dash squared minus cos x. This is what I'm getting. Let me again put x equal to 0 and see this higher derivative test. What does it tell us? 2y0 y double dash 0 plus 2y dash 0 squared minus cos 0. Okay. So the first term is 0, the second term is 0 because of y dash 0 is 0, and the third term is 1. So it becomes negative of 1. So what we are getting is y triple dash 0 is negative 1. Okay. Now we can stop here, because as soon as you get any higher order derivative and its value to be non-zero, you should stop. Okay. Now what we can do? Well, you know that the solution of this differential equation is continuous and it's differentiable, and you are able to find its derivatives. Now if I know that a continuous function, so third derivative will also be continuous. So for a continuous function, if you know that this continuous function takes some value at this point, so let me just, there is a point a, this takes value f of a. So what does continuity tell us? That there exists a small interval such that it keeps the same sign in that interval. You know, even if your function is going like this, in this small interval, it will take the same sign. What does it mean? It will not change its sign. So around 0, around this point, let's see if this point would have been 0, you can find an open interval, let's say 0 minus del to 0 plus del, in which the sign of this function stays the same. If it's positive, it will stay positive. If it's negative, it will stay negative. So for this differential equation, this particular third order derivative is continuous, and around 0, you are going to get the sign of this derivative to be, sign of this function to be same. So I can say that there exists, yes, there exists a number, let me call it del, greater than 0, such that in that small interval around 0, 0 minus delta to 0 plus delta, the sign of triple derivative will be negative. Why negative? Because it took value minus 1 around 0. So if your function is giving you minus 1, there always exists a neighborhood in which you get a negative sign, you know, completely negative. And this is the property of continuity. If you get a positive sign, so there will exist a neighborhood in which you can get, you know, all the values to be positive. So this is what we get here. So rub it here and I will write. So now you realize that y triple dash is 0 in this interval. Y triple dash is, less than 0 for all x belongs to minus delta to delta. This is what we have come up with. Now what we do? If this is y triple dash is the derivative of y double dash, you know, y triple dash. When you derivate y double dash, you get y triple dash. And the derivative of y double dash is less than 0. What does it mean? It means that y double dash is strictly decreasing function in this interval. So for a strictly decreasing function, what do we know? There are two cases, x less than 0 and x greater than 0. for a strictly decreasing function, if x is less than 0, we know that y double dash, which is our function, at x, it will be greater than 0. Because it is strictly decreasing function, it will behave the opposite. If x is less than 0, y double dash x will be greater than 0. If x is greater than 0, y double dash x will be less than 0. Are we clear till here? Because there are a lot of things going on here. So I want you to just take time and understand, because this is a very important question. Okay. So now we'll have to go much deeper. We'll have to make cases again. What does this mean actually? That y double dash x is greater than 0, and all of this is happening in, minus delta to 0. This is happening in 0 to delta. So y double dash x is greater than 0. What does it mean? That y dash is strictly, and why strictly? Because there is strict inequality. Y dash will be strictly increasing function, and here y dash will be strictly, because it is less than 0 for all these points, it will be strictly decreasing function. Now, what does it mean for y dash to be strictly increasing? Here x is less than 0 and y dash is strictly decreasing. That means for x less than 0, y of x will be decreasing. So opposite behavior. It will be greater than 0. And here it will be x is greater than 0. So strictly decreasing. Okay, sorry. It was strictly increasing, and I just wrote that it is strictly increasing. Okay, so y dash is strictly increasing. So if x is less than 0, there will be same behavior that will be reflected. Yx will be less than 0. All right. So in this case, y dash is strictly decreasing. So opposite behavior. X is greater than 0 implies yx will be less than 0. So here we were in this interval 0 to delta. And here we were in this interval minus delta to 0. And in both of these intervals, what we see is that yx is less than 0. So what does it mean? That in this interval, that in this complete interval, yx is less than 0, minus delta to delta. And what does it reflect? There was this thing. Yx is going down. Maybe we made some mistake. X less than 0. This means y double dash is x is greater than 0. Okay. Then it means y dash is strictly increasing. It means that for x less than 0, okay, y dash was strictly increasing. That means y dash of x was less than 0. Yes. And here y dash was strictly decreasing and x was greater than 0. So for x greater than 0, opposite behavior. Yes, we have to stop here. X will be less than 0. Opposite behavior. Okay. Let me just sum up everything, what we did till here. Yes. So we started with our function dy by dx, but it was given that y0 equal to 0. And we find out y dash 0, which was again equal to 0. Then we find out y double dash 0, which was again equal to 0. Then we moved on to y triple dash for the higher derivative test to find maxima minima. But when double derivative test fails and your triple derivative gives you a non-zero value, it means that there is no maxima for this function and no minima for this function. This is a result in calculus. So its fourth derivative, you won't find out the fourth derivative. Only even derivatives can help you determine whether a function has a local minima or maxima. If your odd derivative gives you a non-zero value, then the test tells you that that function has no local maxima or minima. So this means because the third derivative is non-zero, both of these options are incorrect. Now C and D might be, one of these options might be correct. So what we did was, we got y triple dash 0 equal to -1. And since it was a continuous function, it had the same behavior around 0. I mean, there exists an open interval around 0 where it will not change its sign. Its sign was negative. So we said that y triple dash is going to be less than 0. And y double dash will be strictly increasing because of this, because its derivative, that is y triple dash, is less than 0. And some function's derivative is less than 0, that means that function is strictly decreasing. So y double dash is strictly decreasing. We divided into two parts, the interval with positive points and the interval with negative points. The interval with negative points, what we got was y double dash was strictly decreasing. So this means the opposite behavior. So x less than 0, we get y double dash greater than 0. And for x greater than 0, strictly decreasing. The opposite behavior tells us for x greater than 0, y double dash x is less than 0. So we got here. Now on the left hand side, we had this interval minus del to 0. On the right hand side, we had this interval 0 to delta. Now y double dash x was greater than 0. It was a derivative of y dash. So this means that in this interval, y dash is strictly increasing because y double dash is positive. So that means strictly increasing. So y dash is strictly increasing. In this case, y double dash was less than 0. So this means negative derivative in that interval. So that means y dash is strictly decreasing. Okay, we got till here. Then we just wrote what it means for y dash to be strictly increasing, which means that if someone gave you x less than 0 and y dash is strictly decreasing, that is strictly increasing, then the same behavior. If x is smaller than 0, y dash x will be smaller than y dash 0. And y dash 0 is 0 here. So y dash x is less than 0, right? And here y dash was strictly decreasing. So opposite behavior, x greater than 0, will imply y dash x will be greater than y dash 0. And y dash 0 was again 0. That's why I was directly writing 0. So y dash x, sorry, opposite behavior was it. So y dash x less than y dash 0. Y dash 0 is 0. So yes, we got, in both of these cases, what we got was y dash x is less than 0. And the interval was minus delta to delta. So this means, what about y is strictly decreasing, monotonically strictly decreasing function. So option C says strictly increasing and D says strictly decreasing. So C is incorrect and decreasing is correct. If anybody has any doubt in this question, because this was a long question, you can just ask. The motive of choosing this question in this session was to make you realize that not all questions which have derivatives involved in it are of differential equations. They might use calculus also. Okay. So to sum up, yes.
Ma'am, I was trying to discard options like first
Yes,
and
sir.
second option by some observation. Like first option says yx has local maximum at origin. It is asking about origin. So I just observed that my function, like y dash is equal to y square minus 1 plus cos x. Here y function, like one is constant, and cos is also an even function. That means my dy by dx will be an even function. So y will be some odd function like that. So any odd function at origin, it will be neither maxima or minima at
Yes.
origin.
Yes,
So
origin. Because y0 is equal to 0. You're correct, you're correct. See, here it is given that dy by dx is equals to y square minus 1 plus cos x. If you observe, dy by dx is what? A function of xy. So in order to check whether this function is odd or even, what you do is replace x by minus x and y by minus y. By doing so, what you get, dy by dx is equal to negative y square, which is y, minus 1 as it is, plus cos of minus cos of x. So this function as a whole is even. And if some function is even, it's, integration, which is y. That means, dy by dx is even, that means y is odd. Because the derivative of odd function is even and the derivative of even function is odd. So this turns out to be that y is odd. Also, they have given us y0 is equals to 0. That this odd function passes through 0, 0 origin. So our graph may look like this or this. You have some, you'll have some graph here and something like this here, or you might have a graph like this. So you won't find, yes, graphically you can observe, you will not find that maxima or minima at origin. That's a good way to do it. You can also do this way. But for these options, you'll have to be careful because, you have to completely analyze the question and that's how you get it. Okay. Because this will not tell you if the graph is strictly increasing or decreasing. You are stuck in these two cases. So for option C and D, you'll have to solve this question. Use some theorems and figures like we did. So very good. Keep that up. Okay, there are a lot of questions. Let's do them one by one. Just 1 minute. Okay. Let's move on to the next one. And this one says, okay, this is a nice question. For some real number C, where C lies from open interval 0 to 1, let phi be the differentiable function such that phi is equals to 1 and y is equals to phi x is a solution. So phi is nothing but the solution itself with phi. And this is a weird differential equation. We don't know whether we'll be able to solve it or not. Let's see. And which of the following is correct? So phi is a solution. So in terms of solution, they are asking you a relation. So this gives you an idea that they are trying to ask you the solution, directly a solution of the equation. Okay, how do we solve it? Anybody? Any hint? Is this solvable differential equation? We have studied many methods to solve differential equations.
Homogeneous differential equation.
Okay, someone is saying homogeneous differential equation. Yes. This is a first order differential equation. You can go for homogeneous or maybe exact. If it's not exact, making exact. So whatever you like. Yes, anybody?
By some substitution, we can change this in variable separable form, then we can solve it.
How, what kind of substitution?
Like y is equal to vx.
Yes, that substitution is related to homogeneous differential equation. Why homogeneous? What you are saying is part of homogeneous differential equation. So what we are saying is this power is 2, this power is 2, and this power is also collectively 2. So this is a homogeneous differential equation. This is directly visible. But if you want to solve it by exact, you will find your m is, x square plus y square. I'm just giving you a hint. And minus 4xy is your n. When you differentiate with respect to y, you get 2y. And when you differentiate with respect to x, you get minus 4y. You can just use one of these methods, del m by del y minus del n by del x divided by m or n, whatever. You can see this is a function of x only or y only, you know that. So let us just solve it. Please solve with me, solve with the help of homogeneous differential equation. Sorry for that. Okay, so let us substitute. Before substituting, let me find dy by dx. dy by dx is basically nothing but 1 by 4 x by y plus 1 by 4 y by x, something like that. If I substitute y by x equal to v, I'm going to get y equal to vx, which is dy by dx is equals to v plus x dv by dx. We already know. So let us just substitute. We get from this equation, what we get is v plus x dv by dx is equals to 1 by 4, and x by y is 1 by v plus 1 by 4, y by x is v. So when we go and solve for it, it becomes 1 by 4v minus v by 4 minus v. So let me just take LCM, I don't know, 1 minus v square minus 4v square. So this is 1 minus 3v square by 4v. Okay. Now this becomes variable separable, and you can easily separate those variables. It becomes 4b by 1 minus 3v square dv is equals to dx over x. Very nice. What we can do now on the left hand side? Any idea?
Multiply and divide by 6.
Multiply and divide by 6. On the denominator, you see that there is a polynomial. There is a quadratic, and on the numerator, we have a linear. So this means that you can make it like f dash x over fx form. So in order to do that, we know that the derivative of this thing is minus 6v. So let us multiply by minus 6 and divide by minus 6 and just solve for it. Now it's very easy to solve. So this will be equal to minus 2 by 3 log of 1 minus 3v square is equals to log x plus log c minus, so if I directly write it, log of, I'm just removing log from both sides. This will be equal to cx. This will be our solution. Minus 3v square is equals to cx. But they have given us one condition, and also I'll have to put v is equals to y by x. So after doing that, 1 minus 3y square by x square minus 2 by 3 is equals to cx. What do I get? X square minus 3y square divided by x raised to power 2 into minus 2 by 3 is equals to cx. 2 minus 2 by 3. Negative 3 by 2 it will be. Oh, sorry. It will be 3 by 2. So this will cancel out. I guess it will be x square minus 3y square raised to power negative 2 by 3. It will be cx into x cube, I guess, if I'm not wrong. And the given condition is phi 1 is equals to 1. Given condition is, if you put x equal to 1, you get y equal to 1. Yes, so it will be 1 minus 3 raised to power, cubing both sides. I think I've made some mistake somewhere.
Yeah.
Cubing both sides.
In above x square minus 3y square, there should be also power minus 2 by 3.
Minus 2 by 3. But there is one more mistake, I guess. What we can write it as is, we could have written this as x square minus 3y square minus 2 by 3. Or in another way around, cx into 1 minus 3y square by x square by 2 by 3. Taking this negative power this side, so it will become like this. Cx into x square minus 3y square whole raised to power 2 by 3 divided by there is something maybe equals to 1. X square raised to power 2 by 3. It should be 4 by 3 then. Cx 1 plus, sorry, Cx raised to power 4 by 3, 1 plus 4 by 3. X square minus 3y square raised to power 2 by 3 is equals to 1. It will be x raised to power 7 here.
This c into x raised to 1 minus 4 by 3, right?
1 minus 4 by 3. Okay, got it. So this will be negative 1 by 3. X square minus 3y square is equal to 1. So let us substitute x is equal to 1 and y is equals to 1. What do we get? We'll get 1 here, 1 minus 3. 1 minus 3 here. So it will be minus 2. So before that, we can also do one thing. C into cubing both sides. C into x raised to power minus 1. X square minus 3y square raised to 2 is equal to 1. Now x is equals to 1 and y is equals to 1. What do we get? 1 minus 3 minus 2. This will be 4. This will be 1. This will be 1. Okay, so c will be equal to 1 by 4. So substituting the c is equals to 1 by 4 here. 1 by 4 x inverse x square minus 3y square whole raised to power 2 is equal to 1. This is our final solution. You can substitute y is equals to 5. So what do we get? X square minus 3y square. Taking this on the other side, we get 4x. X square minus 3y square whole square is equal to 4x. Okay, let's see. X square minus 3y square whole raised to 2. Okay, option 1 and 2 matches is equals to 4x. But option 1 has plus sign, but we had minus sign. You can write x square minus 3y square or 3y square minus x square because it's a whole square. So it doesn't matter. So option B will be correct option. I'll have to be careful with calculations. I do a lot of mistake. Okay. Does everyone got it?
Yeah.
Okay, very good. You guys are pretty intelligent. Okay, now let's move on to this question. This is an interesting one. This, this is a linear differential equation. We'll solve it with auxiliary equation and particular integral. It has constant coefficients. So if I write this in a simplified form, I get this. But A is unknown and the options are made according to A. What choice of A we have? And in the above statements, they have given the definition of a periodic function. So let's see how it will help us. So if I find auxiliary equation, I get d square plus 4 is equals to 0, d is equals to plus minus 2 iota. And according to this, the complementary function should be y is equals to c1 cos x, cos 2x plus c2 sin 2x, right? And for the other part, particular integral, let's see what it will give us. 1 by d square plus 4 into sine ax. Now, for this trigonometric function, what do? We'd replace d square by minus a square in case of sine and cos. So when we'll replace d square by minus a square, we are going to get minus a square plus 4 sine ax. Right. But if this a is equals to plus or minus 2, it will create a problem because this will become a case of failure. And when this will become a case of failure, we will have to multiply the numerator by x or x multiple times, or maybe one time. But when we do so, in case of failure, when we multiply numerator with a, let's see what happens. Let's say a is equals to 2. So we'll have to do this derivation in the denominator with respect to d, and we'll have to multiply it with respect to x. We'll get something like this. But every option is talking about periodicity. Let's see. Before solving complete question, just have a look at the options, whether you have to solve it fully or not. So every question is talking about the periodicity of the solution. In this case, the solution cannot be periodic because our complementary function was periodic and this particular integral is not periodic. So sum of the two functions, a periodic and non-periodic, will not be periodic. So this means that a cannot be equal to plus or minus 2. This is our first observation. Okay. Now, next observation we should make is start reading the options. First option says all solutions are periodic for every choice of a. This is incorrect because if we take a is equals to plus or minus 2, then solutions won't be periodic because of the particular integral that I told you. So I will discard this option. All solutions are not periodic for every choice of a. All solutions are periodic for every choice of a belongs to R minus 2 to 2. And third option says a belongs to Q minus 2 to 2. And fourth option says if a belongs to irrational, then there is a unique periodic solution. Okay. See, in this question, there is this thing, rational, irrational thing. So let me take a is equals to root 3. Let's see what happens. In this case, it will be c1 cos 2x plus c2 sin 2x. 2x plus. If a is equals to root 3, it will be something, some constant, 4 minus 3, 1, I guess, sine root 3 of x. Constant is of no use, but I just want to draw your attention to this sine part. So all of these functions are periodic, right? But how do we find the period of sum of periodic functions? In case of trigonometric functions, how do we do that? Is that its period is pi, because its period is 2 pi divided by this coefficient 2. So it is pi. In this case, it is also pi. In this case, the period is 2 pi divided by the coefficient, that is root 3. This whole solution will be periodic only if this is a result in periodic functions, that this can be periodic if you are able to find the LCM of these two. Suppose if we had pi and 2 pi, finding the LCM of the coefficients of pi, here it is 1, here it is 2, finding this LCM would have been easy. It would have been 2 pi. Or you would have something like 2 by 3 pi, comma 1. In this case, LCM would have been, 2 pi. LCM would have been pi or something. Pi or 3 pi something. But in this case, when you encounter a irrational number, in this case it is not possible to find a period, find a LCM for this too. So in this case, in these type of questions, you won't be able to find period. So it will not be periodic. Only condition is that these have to be integers. The numerator and denominator have to be integer. Only then you will be able to find the LCM of the two terms. But if one of them is irrational, you won't be able to find the LCM. So keeping one irrational number won't allow you to find the period, any irrational number. So option A contains all the irrational numbers. So option B. Option B is incorrect. But option C contains only rational numbers, any numbers which are of the form P upon Q. And P is integer, Q is integer. As I already told you, numerator and denominator both have to be integers. Only then you will be able to find the LCM. So option C is correct. Option C says that for any A belongs to R minus Q means for any irrational number, there is a unique periodic solution. It won't be, because for any irrational number, you won't be able to, solve for this. So only correct option will be D option. Irrational numbers won't work for the linear combinations of these trigonometric functions. If there would have been this solution alone, you could have easily find the period. But we need to find here the total solution, I mean total period for all the linear combination of these solutions. Okay, so this is our 35th question. Now let's move on to the next one. This is a very simple question. I hope you can do this. I will give you a hint because we have limited time, so we'll move on to next question. This question can be done with the help of, this is a linear differential equation. Also, they have asked the limit x approaching to infinity on y. That means you'll have to solve for this equation. Also, this is a numerical answer type question. You won't be able to guess any option. So this differential equation demands you to solve this question. And you can see that if you see that p is equals to 3x square and q is equals to x square, you can easily solve this differential equation. I guess answer would be 0 or something. You will easily get the answer. I don't remember the answer, but yes, you can solve this. So we'll move on to next one. Okay, this is an interesting one. How do we solve for this? I want to know. Can we rewrite this as something interesting? Let's do it. X square xy square y dash plus y cube is equal to sine x over x. Now this is not a linear differential equation, by the way. What we can do? Other than linear differential equation, we have reducible to linear differential equation of first order, which is also called Bernoulli's equation. Do you remember?
Yeah.
But you don't have to remember the Bernoulli equation. You can just directly substitute. See, if I simplify this in this form, y dash, if I divide, I'm dividing the whole equation by x. What happens? Y cube is equals to sine x over x cubed. Right. So now how do we solve for this? If I substitute y cube is equals to some z or t, I'm going to get 3y squared dy is equals to dt. dy over, I substituted y cube is equals to t, dy over dx is equal to dt over dx. But I also need 3 here, right? So let's do it. Let's multiply everything by 3. We can do it.
Yeah, x square. Sin x by x square.
X square, right? Sin x by x square, right? So just do one thing, substitute it with z or t, whatever. Then we will get 3y square dz over dx is equals to dy over dx is equals to dz over dx. And this becomes dz over dx plus 3yx, x is intact as it is, y cube is z is equals to 3 over x square sine x. Now this is a linear differential equation and you can easily solve it. Okay. Well, this question has answer 0. Do you want me to solve it completely? Let me see if there is one more question which will take time. And yes, we have 2 questions which I want to discuss, 2 or 3 questions. Do you want me to solve this or will you be able to solve this? I think its answer will be 0 as far as I remember.
Ma'am, we can solve it.
You can solve it, right? It's
Yeah.
a very easy question now. Very good. So let's move on to next one. Okay, this question says, let C be the minus C to C be the largest open interval where C is either positive real number or C is infinity, on which the solution differential equation the solution of the differential equation exists and it is unique. So we have been given a initial value problem, right? This is a first order differential equation, but this is not linear. There is another problem. How do we solve it? Do we actually need to solve it? Let's see with the options. They've asked you y is an odd function, y is an even function, y square has local minima, maxima. This is similar question to what we did previously. So what can we do? Odd and even in option 1 and 2 give us hint that we can check dy by dx, which is a function of x and y, to be odd or either even. How do we check? I replace x by minus x and y by minus y. So let's check. It will be minus x squared plus minus y squared plus 1, which will be x squared plus y squared plus 1. So this means dy over dx is even. This means that yx is an odd function. Yx is an odd function on minus c to c. Because, as this is even, so this means y is odd. So y is odd and not even, so A is correct, D is incorrect. So what about y square as local minima or not at x equal to 0? Okay, let's try to analyze this. How do we do it? I mean, y is an odd function. It gives us that y may have a diagram like this. In the opposite quadrant, the odd function have the same symmetry, or it might be something like this. Does it pass through 0, 0? Yes. It passes through 0, 0, so we can have a function like this. But y square, see, if they would have given this y has a local minima or not, then this option would have been incorrect. But they have asked you y square. So suppose our function is like this in the first and third quadrant, then squaring this function will do what? It will change the shape of the function a little bit, and along with that, what it will do, it will move this part of the graph to the, in the second quadrant, right? It will just shift the graph up. And in this way, graphically, we can see that 0 will become the point of minima. Are you able to get me? So, minima. Yes, whenever you mod a function, what happens? Whenever you take an absolute value of the function, if I give you a function y is equals to x, you will draw the graph very easily. But if I ask you to take the mod of this function, what do? You just shift the graph from this side to this side, because you are taking the positive value of y. Sorry, it will be touching here, right? So mod function or squared functions are always non-negative. So their shift from third quadrant to second quadrant or fourth quadrant to first quadrant. And that's what we did here. We don't need the shape of this function. This function was continuous. That's why I drew this function like this in a continuous way. This function was a solution of differential equation. It was purely differentiable and continuous function. I was able to shift the graph. I was able to take the mirror image along the x-axis because I squared the function. And graphically, everything is very clear that C option is correct. It has a local minima and D is incorrect. So answer is A and C. And this was a beautiful question. It did not involve any differential equation, you see. So just because they have given you a differential equation doesn't mean you have to solve it always. You have a lot of calculus knowledge to apply to. Okay, now let's move on to the next question. This question is of orthogonal trajectories. It's a nice question. It will take a lot of calculations and something, I think. Let's see. Y is equals to c into 1 minus cos x divided by sin x is our family of curves. Let F2, so this is F1. Let F2 be the family of orthogonal trajectories to F1. So the F2 is the family of orthogonal trajectories to this family of curves. So consider the curve C belonging to the family F2 passing through this point. So there is a particular curve, because orthogonal trajectories is a family of curves. There are infinite curves there. But they are talking about a particular curve C that belongs to this orthogonal trajectory family of curves and passes through this. Okay. If there is a real number such that this lies on C, they have given another point that lies on that curve, then a raised to power 4 is equals to what? This question will just take calculations from your side. Okay, so let me start this question and you can just continue with this one. This is our family of curves. And why I'm saying family of curves? Family, why? Because C here is a arbitrary constant. C is a positive real number in this case. You can take, infinite, uncountable values of C and you can get numerous curves. So this is a family of curves. In order to find the differential equation for this family of curves, you need to remove this arbitrary constant. That's what we did in chapter 1 of ordinary differential equation in our college maths, right? Removing the arbitrary constant. That's what we are going to do here. You can just simplify this. I think we can just apply the formula 1 minus cos x is 2 sine square x over 2 divided by 2 sine x by 2 cos x by 2, right? And I'm just trying to cancel it, but my pen is not working. It's become slow. Okay, so y becomes tangent x by 2, right? C times tangent x by 2. dy over dx will become secant square x by 2 and coefficient will be multiplied. So simply, what is my C? C is 2 times cos square x by 2 dy by dx. This is what it is. Now I can substitute this C in the original equation. If I substitute it here, because I've already changed the original equation in the tangent form. So y is equals to C times tangent x by 2. C times. So C is 2 cos square x by 2 dy over dx tangent x by 2. I think you'll be able to solve for it now. You will be getting a differential equation of some form here. And your next task is to, this is F1, right? And your next task is to find F2, the family of orthogonal trajectories, where you'll have to replace dx by dy by minus dx over dy. Okay? And then when you solve for it, then when you will apply your methods of solving differential equation, you will get y. The family of curves. So y is equals to some phi x. And what will you do next? I'm not solving this question completely because it will take time, but I will give you the answer. The answer of this question is a raised to power 4 is equals to 2. So the answer is 2. If you still have any doubts after the session, you can anytime ask me. I'll be available to answer all your questions regarding these questions. You can just practice them. It's a whole lot of calculations. We won't go much deeper into calculations. You will get y is equals to some curve, and then you will substitute this point pi by 3, 1. And then when you substitute x equal to pi by 4, you must get a value of a. As simple as that. Okay, cool. Can we move forward? I just want your concepts to be clear in this session. Okay. Anybody having any doubt in the previous question? We were given a family of curves. We differentiated. We found the differential equation. We replaced dy over dx by minus dx over dy. We again integrated and found the orthogonal trajectories. And then what we did? Applied the two conditions that were given to us. As simple as that. Okay. Okay, but if you still having any doubt in any of the question, you can always ask me. Let's move on to this question. Okay, what does this say? This is a linear differential equation of second order with constant coefficient. So we are seeing a pattern in IT JAM exam that linear differential equation of second order with constant coefficient is a must-go question. Linear differential equation with first order is also very important to IT JAM. Exact differential equation, there must be a question. Along with that, some questions to confuse you where dy by dx is given to you, but it does not use any of the differential equation, but just calculus. So be ready with that. Your upcoming exam might have all these kind of questions. How do we solve for this question? This is an interesting one. Although the equation is simple, but options might confuse you. So let's just solve for it. B square plus AD plus 1 into y is equals to sine x, right? So let me just put a is equals to 0 because I won't be directly able to solve it from here. So if I put a equal to 0, case 1, it will become d square plus 1. So auxiliary function will be c1 cos x plus c2 sin x, because you'll get t is equals to plus and minus iota, and then you know how to solve for it. Actually, OneNote is getting very slow. It's okay. What will be the particular integral in this case? Please tell me what will be the particular integral if I put a is equals to 0. What would it be? We'll have to replace d square by minus 1, and then you will get a case of failure. And then you'll have to go and multiply the numerator by x. As soon as you multiply the numerator by x and integrate, you will get some x into some trigonometric function term. So you don't have to solve for it, number one, as I did not solve for it. You just realize that in this case of failure, the auxiliary, the complementary function is a complete bounded function, but the particular integral will be unbounded because of x. So option A says if a is equals to 0, then all the solutions are unbounded over R, which is true because of the involvement of x. Then when a is equals to 1, what happens? Let's put a is equals to 1, then we'll go for a is equal to 2. 1, sorry. Your equation will be d square plus d plus 1 into y is equals to sine x, right? So for the, I will get the roots will be minus 1 plus minus, plus minus. It's very slow. It's going very slow. Minus 1 plus minus under root 1 minus 4 divided by 2. Okay. Right. Again, these are, this will give you complementary function as, you can solve with me. Complementary function will be y is equals to e raised to power minus x by 2. C1 cos, root 3 by 2 iota plus C2 sine root 3 by 2 iota. Okay, they are saying that the solutions are unbounded from 0 to infinity. Obviously, the complementary function seems to be bounded because this is bounded, and from 0 to infinity, this is also bounded. Now let's talk about particular integral. That will tell us whether it is bounded or not. The particular integral will be 1 by d square plus d plus 1 into sine x. Okay, so let me just tell you. When we replace d square by minus 1, what we'll get? 1 by d of sine x. E square by minus 1 plus 1, you're going to get 0. So 1 by d, integration of sine x, what will it become? Minus of cos x. So minus of cos x is again a bounded function. So b is incorrect because of unbounded, but we are getting bounded, so b is incorrect. He is saying all the solutions tends to 0 as x tends to infinity. This is actually not true, because these solutions will go to 0 as x tends to infinity. But what about the particular integral? Particular integral is this. It will not go to 0 as x approaching to infinity, because it is oscillating. It has an oscillating behavior cos x at infinity. So C is incorrect. And D, what about D? D is equals to -1. You can just analyze this option as it is. Let me do it for you. 1 by d square plus 2d plus 1 into y. So you get d is equals to -1, comma -1. Your complementary function will be y1 e raised to power minus x plus y2 into x e raised to power minus x. And your particular integral will be sine of x d square plus 2d plus 1. So let us replace d square by -1. We'll get 1 by 2d sine x. And it will be 1 by 2 cos x. Right? So this plus this is our solution. Now they have asked you, all the solutions are bounded over -infinity to 0. This is bounded. Our particular integral is bounded. This is bounded. But is it bounded? -infinity to 0? -infinity to 0. Actually, this is not bounded. This is unbounded. But they are saying it to be bounded. So option D is also incorrect. My one note is hanging. Sorry for that. This was the last question actually. Okay. Did you get it? I know I messed up in the last question because of so much difficulties in writing, but I want you to get the idea of this question. And I hope I did all the calculations correctly. You can just analyze. You know how to analyze these kind of questions. You just find the solution according to a is equals to 0, a is equals to 1, and you see if it's bounded or unbounded. It is simply a question which you have to do by the options. Okay. So this is it from me. In today's session, we have done 2 previous years, 22 and 23. I hope you enjoyed the session. If you have any doubts, you can take it now. Over to you, sir.
Okay, thank you, Unnati, for this nice session with a good collection of problems.
Thank you, sir.
Dear participants, now it is a time for interaction. Okay, dear participants, now it is your time to share your feedback, and also you can ask your queries regarding the preparations.
Good afternoon, sir. Good afternoon, ma'am. Ma'am, I'm Shika, and I'm from Jharkhand. I've completed my integrated MSc in Mathematics and Computing from Birla Institute of Technology, Mishra. And ma'am, today's session was really amazing. Like you have given tips to do question in each and every step, and you just explain each and every options very clearly. It was really easy and understandable. Thank you, ma'am, for taking time for us. Ma'am, I need a few tips for GATE aspirants. Like we are having GATE exam also. So I want few tips from your side.
I think you might have completed already the syllabus which you should have been covered. I think it's time for now you to focus on solving mock tests, because it is a very crucial time for you. So now focus on all the PYQs. If you have solved all the PYQs, go for mock tests or test series so that you can analyze yourself at least 4 to 5 days before the exam. But if you're fully prepared, you can just leave preparation before 1 week before the exam. But at least for now, you should focus more on solving either PYQs or test series. Test series are very important to analyze your performance. you should know in a limited time how much you can perform, and work on your strong skills now, not on your weak skills, weak areas. Try working on your strong areas. Like if for me, calculus or differential equation is strong, then I will work on more on that, so that I don't leave the question in the exam. But if some question is difficult in the exam, also I want to mention that some students make this mistake of taking very questions very close to their heart. It is not that. If your real analysis is your strong part and some question is very difficult in the exam, please leave it, because there are numerous questions to do. You won't be attempting every question in the exam. So just try to do all those questions which are easy for you, average for you, not very difficult for you, because it will take your time. So these are some of the tips from me. If you want to ask anything more, you can.
Thank you, ma'am. Thanks a lot. Thank you, Vinod, sir, for organizing such sessions. Thank you.
Thank you, Sikha.
Good morning, ma'am. Good morning, sir.
Yeah, Titi.
Hi, Titi.
Yes.
Yeah. Ma'am, firstly, I want to thank you for today's session. It was very helpful for us as our exam is next Sunday. So it was very helpful for revising all the concept of OD. So thanks for your effort and the class you take. Ma'am, I want to ask you about the exam strategies. That you have a very good rank in GATE and as well as in JAM also. So what was your strategy to attempt the exam, or what you kept in mind during the examination so that you obtain such a good rank in exam?
Actually, during the exam, the first thing, the most important thing is to stay relaxed. Don't pressurize yourself with everything. Secondly, I attempt exams in 2 attempts at least. So I go through the easy questions first. I see all the questions first which are easy and attempt them. And in the second attempt, all those questions which I have marked for review and those which I thought I would be able to do, and I get back to them. I mark for review them. It's a very nice option during the exam. So do that, do the exam in at least 2 attempts. Okay. And I focused on my strong points. I don't do each and every part of the syllabus. I believe in focusing on the strong parts. So you can do that too.
I mean, in GATE examination particularly, there are 65 questions. So how many questions you attempted in the exam in your time?
I don't exactly remember, but there were not many questions I attempted. I actually got good marks in the aptitude part. I got 11 out of 15. For me, that in 2022, I thought aptitude was easy. But you should not make this mistake of attempting too much questions in the aptitude part, because it might take your marks. Attempt only those questions which you are confident with.
Okay.
And for maths portion, I mainly attempted real analysis, complex analysis, group theory. Mainly these parts of the syllabus which are common to CSIR-NET. Because I didn't specifically prepared for GATE this time in 2022. So this was my strategy. And I guess, I don't exactly remember. I'll give you a wrong number if I say that I attempted this much number of questions. So I won't say anything. I don't remember exactly. But don't try to attempt too much. Yeah.
Yeah. Thank you, ma'am.
Thank you.
Thank you, sir, for organizing this session.
Okay, thank you. Thank you, Titi. Yes.
Morning, ma'am. Good morning, sir.
Yeah. Yes, I am.
Thank you, ma'am, for this wonderful session. It was really helpful. The way you explained the questions was really easy to understand. And thank you, ma'am, for the last minute tips also. Thank you, sir, for the session.
Thank you, Shreya. Yes, Sneha.
Yeah, thank you, sir, and thank you, ma'am, for the session. It was an amazing session. I revised all the OD concept almost, I think. Ma'am, I have question. Like, I am going to write this GATE exam, but since I'm an MSc first year student in 𝐼SER-UGC, so I have so much things in academic to do. I don't get any much time to prepare for that. For GATE exam, I have done nothing. Like all the time, I am busy in academics, but I will give exam this time. I have just 1 week, so if I want to just clear the exam, just clear the cutoff. So what can I do now? Like in 1 week? Yeah, I have studied all the concepts since I am in M.Sc. So jam level syllabus I have done, but for the GATE exam I didn't do anything.
If you have done the JAM level syllabus, it will be easy for you to revise all those concepts. Just revise what you know. Don't jump into new concepts. You know that before the exam you won't be able to get deep into those concepts. So don't go for new concepts first of all. If you, let's say if you have done group theory for IIT JAM, just revise all those concepts and all those previous years of JAM first. And then if you have time left, you can go for GATE questions, collected previous years of GATE exam. First solve for IIT JAM questions, because these are the two exams that IITs are making. So they have sort of similarity between them. CSIR NET is a different exam. It focuses more on your conceptual knowledge, but GATE and IIT JAM exam focuses more on sometimes numerical part. And so you can just relate the two exams, and IIT JAM's exams is a subset of GATE exam. So first of all, try to solve as many questions as of the IIT JAM exam, and then you can move on to GATE exam. Just try to do all those concepts which you already know, and that's it. Don't pressurize yourself with the new syllabus now.
Okay.
Okay? Okay, Sneha.
Okay.
Yeah, thank you, Sneha. Yes, Dharmendra.
Good morning, sir. Good morning, madam. Good afternoon. I am Dharmendra Singh from 𝐏𝐘𝐐'𝐬, UP. I joined today's session some late. The session was very nice, and trajectory problem also very interesting problem. Can we please can you tell about some books also, except SL Rose or ML Rai Singhania?
Basically, I followed SL Ross and MD Rai Singhania. So, but there was one book our sir used to tell us, but I don't remember exactly the name. There is a very good book, but I'll have to. There is also a book, Calculus by James Stewart, I guess. This book contains differential equations portions also. You can go through that book. This is a very nice book of calculus. It will give you an idea of about calculus, real analysis, differential equations. It has many problems to solve. But for these exams, I think MD Rai Singhania and SL Ross are enough. But if you want to study extra, this is James Stewart is one book that comes to my mind.
Okay. Okay. Thank you, ma'am. Thank you, sir.
Thank you, Dharmendra. Yes, others.
Hi, sir.
Yeah. Yes.
Sir, my name is, I'm 𝐏𝐘𝐐'𝐬. I'm a second year BSc Mathematics student from Kerala. I found today's session really helpful. I was able to learn a lot of new concepts. Ma'am, I would like to ask you some book suggestions for beginners differential equations. Actually, I have not covered a lot of concepts, and I would like to know which is a good book for starting.
So if you have covered your differential equation in the college syllabus, first of all, you should follow your college.
I have not covered actually.
Okay. Then you can follow MD Rai Singhania. It's a very Indian book, and Indian books give you, more of this basic idea of differential equations. And then you can go for SL Ross. SL Ross is a nice book to follow. If you want to have a very basic idea, just go with MD Rai Singhania, I would say. First go with Indian author, then you can move to some foreign author.
Okay, ma'am. Thank you.
Okay, Gopika.
Thank you, Gopika. Yes, others.
Hello, ma'am. Am I audible?
Yeah,
Yes.
yes.
Okay. Hasna.
I am Hasna Sharin, second M.Sc student from TMG College, a student of Vinod sir. The session was very informative. Actually, I was really worried about this type of differential calculus questions, and ma'am handled it very easily. Thank you, ma'am. It was really helpful for me, and the last minute tips are very useful. Thank you, ma'am, and thank you, Vinod sir, for this free sessions.
Yeah,
Okay.
thank you.
Good afternoon, sir. Good afternoon, ma'am. My name is Ramakan. I'm a second year student from Kerala. So, ma'am, I would like to know what book would you suggest for real analysis?
For real analysis, you can go for Bartley and Sherbert. But if you want to start with the very basic real analysis, I would say there is a book for called SK Mappa. Depends on it's at which level you are. You want to go with the basic one?
Yeah, ma'am, I'm a beginner. I'm a second year student.
You're a beginner. So you can go with SK Mappa or S. Kumar Sen's book. But firstly, I would suggest you to go with SK Mappa. This will give you a very basic idea for real analysis.
Thank you, sir. Thank you, ma'am. It was a wonderful session.
Thank you, Ramakan. Yes.
Hello, ma'am.
Yes.
Hi.
Hello,
Yes,
ma'am.
Sakhi.
I'm Akita from TMC College, Tirur, Kerala. This class was very interesting. You explained each question clearly. Thank you, ma'am, for your valuable time with us. And thank you, Vinod sir, for conducting this class. Thank you.
Thank you, Akita.
Good morning, ma'am. Good morning, sir.
Yes.
I'm Parvati from St. Teresa's College, Kerala. So the session was really good. The way you explained each question made me feel easier to attempt the question. Thank you. Thank you, sir, for holding such a session.
Unnati, I think you remember Parvati.
Yes, sir. I remember Tithi and Parvati. I met the two.
Yeah, yeah. Yes. Yes.
I think Sri Lakshmi
yeah.
wanted. She has been waiting for a long time, I guess. It's okay.
Hi, sir, and hi, ma'am. Your class was really nice. I'm preparing for GATE right now. I'm from Kerala. So your coding session was really good. This is probably the first class I'm attending of you. Yeah, it gave me a good understanding. Like, for GATE also, I think it's kind of helpful, and all these tips you gave is really nice. Thank you so much. And thank you, sir, for conducting this session.
Thank you so much.
Thank you, Sri Lakshmi.
So thank you, Unnati, for this class. Hope that hope that our students will perform good in the coming examinations.
Yes,
and I request you to be with Math Aspirants community in future too, and wish you all success in your academics and career.
Thank you, sir. Thank you so much.
Yeah. Okay, thank you everyone. Let us wind up here.